I take an immense pleasure in welcoming you all for the 5 days virtual faculty development
Recording
program
in progress.
on research perspective on data science conducted by the Department of Information Technology of Sairam Engineering College. And we also thank every individual for making the Day 1 event a grand success.
I now invite Dr. Adeline, Professor, Department of Information Technology, to welcome the gathering. Please, ma'am. Ma'am.
Yeah. Yes, I take this opportunity to welcome you all for the day two of this FDP. So here the guest is Doreen ma'am. Today and tomorrow she'll be handling this session. She had taken the medical application and she will proceed with that. So all of you kindly be in this session and try to get more information. Thank you all.
Thank you, ma'am. Opportunities don't happen, you create them. We next invite our speaker of the day, Dr. D Doreen Robin, the Director of Computational Intelligence Research Foundation. She received her BTech in Information Technology from Madras University, Chennai, ME and PhD in Computer Science and Engineering from Anna University, Chennai.
Her research interests include parallel and distributed computing, peer-to-peer computing, with computing, cloud computing, and big data analytics. Previous positions include Professor and Head at Loyola ICAM College of Engineering and Technology in the Department of Information Technology, Assistant Professor at the Department of Computer Science and Engineering, Sri Venkateswara College of Engineering, Chennai Teaching Research Associate at the Department of Computer Science, Anna University, Chennai, and Assistant Professor at the Department of Information Technology, Assistant College of Engineering, Chennai. She has published about 30 papers in the international and national journals and conferences. She is a lifetime member of ISTE. She is a reviewer for Computer and Electrical Engineering Journal and Future Generation Computer Science Journal. She had been the resource person for the workshop on digital classroom, big data analytics using Hadoop, data science using Python, machine learning, deep learning, and cognitive computing, software testing, blockchain technologies, cyber security, and cyber forensics. I now invite our beloved speaker, Dr. D Doreen Robin, ma'am, to share her valuable cognitions on the topic classification of predictive healthcare analysis. Please, ma'am.
So thank you all for the warm invite and a very beautiful introduction. First and foremost, I would like to thank the college, Sairam Engineering College, for having invited me to give a talk on this topic, classification model, okay, on predicting the healthcare, I'm presenting my screen. I hope you're all able to see it.
Yes, ma'am.
Yes, thank you. First and foremost, I would like to thank the chairman and CEO, sir, and Prakash Leamuthu, sir, the principal, Rajendra Prasad, sir, Dr. Rajendra Prasad, sir, especially the Department of Information Technology, the head of the department, Dr. Sheila, ma'am, and the coordinator of this event, Dr. Adeline, ma'am, and all the beautiful participants from different destinations of the world having joined for the 5-day virtual FDP on research perspectives on data science. So yesterday, you should have got about the fundamentals of data science. All right, today we have a two-part of the sessions. Today we are going to learn about classification, how to develop a predictive model. The data set that we are going to use is the healthcare analytics, okay? And tomorrow also, we'll be seeing about clustering, how to cluster the customers onto a market, all right? So hopefully you are able to see my screen. Yes.
Yeah.
Thank you. So before I start with my session, whenever I ask a question, right, I want your answers all on the chat box. All right. The first question for the day, we are going to deal with data, so we need a lot of data to work on with. How are you today? If you're fine, you can put fine, you're excellent, or whatever it is. How are you today? on 29 June 2021 around 4:10. Fine, thank you, Surya ma'am. You can just give in a simple word. Thank you, Piyush sir. Excellent. Thank you, Mohammed sir. Fine, ma'am. Thank you, Shruti. Good. Wonderful. Thank you. Gomati ma'am. Thank you. Bharani Dharan sir. All right. Okay. Wonderful. Fine. Anita ma'am. Fine. Okay. Dr. Chenny Kumaran sir. Good, ma'am. All right. Yes, we have got 65 participants and we have got around 10-15 others. Thank you, Celine ma'am. You're fine. Jairat sir, you're fine. Okay. So I just asked you all a very Ravikumar sir, fine. I just asked you all a very simple question. How are you today? All right. And you almost, I could get the sense of it, or is it positive? Okay, we praise and thank God for it. So, but the words are different, right? It's good, it's fine, it's excellent, all right, wonderful, okay, but all denotes that you're all fine, all right? Yes, you're very comfortable. Thank you, Abdul Rashid sir. So each of you, you have given your thing. As humans, we will be able to process it. Today, we're going to see how the prediction is. What's the target? I want to know, how are you today? There are two possibilities. Either you're good or you have some difficulties. Most of the answers you have given that you're fine. So it is a positive note. Okay. How to predict it, how to make machine to learn, and how to predict it. Okay, that's what we are going to see about today. Okay, and how many of you are using laptops or mobiles? If you're using laptops or PC, you can just give the first letter L or P. If you're using mobile for this workshop, you can give M. Yes, thank you. Yes, thank you. Thank you. Some of you are mobile, some of you are using laptop, PM, laptop. The reason behind I'm asking this question is that after 1 hour of this talk, of the theory session, we are going to have a hands-on session. Okay, I just want to know if you're using your laptops, it will be more comfortable for you to work on with that. Okay, hearing is okay, but when you do work with the data, you will feel the goodness of the data science. All right. Okay. So today we are going to see about the classification, the predicting healthcare analytics. All right. Healthcare is most important domain for predictive. Okay. About taking care of the health. Okay. I know everybody, you should have stepped in one step forward after March 2020. Yes or no? Taking care of your health. Generally, we take care of your health. The more emphasis we have started giving, wearing mask. How many of you were wearing mask before March 2020? Yes, no? Whether you are wearing mask before March 2020. Yes means Y, no means N. No, you weren't because we were not aware of it, right? The word corona is also, it has become a universal syllabus. Okay, then nobody learns anything, but most of us know about it. Right. Somebody's mic is on. Kindly put your mic on mute. Okay, okay. So, yeah. So no, but see, we have all started taking, wearing mask, taking steams, okay, and more we focus on to our health. Before, if we get cold also, we just ignore it, it's just a cold. But now, if you get a simple cold itself, a lot of permutation and combination happens in the brain. What really is happening to my health? Okay, so healthcare is a very important as a personal, and also in analytics, it has a wide great spectrum of application. Okay, so how do you make a predictive model? You make a predictive model using a historical data. Okay, you develop any application. It could be, it's not only healthcare, it could be climate. Okay, it could be the students' performance, it could be the disease prediction, it could be the sales. All right, it could be how the market will flourish or not. Okay, any sectors you take, if you want to develop a predictive model, you use historical data, learns from it, finds pattern, and generate accurate predictions from it. So these are the steps. When you want to develop a predictive model, you use historical data, You learn from the data, find patterns, and generate accurate predictions. Since this one is a faculty development program, how many of you are teaching in a university or in a college? How many of you are into the teaching field? If you are a teacher or professor in any university, type yes or type no on the chat. Quick. Let's have your answers. Yes, yes, teaching. Yes, 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 yes. So you are all brilliant and beautiful teachers. Yes, assistant professor. Thank you. Every one of your teachers, right? Okay. So when a student comes to the first day of the course of your college, will you know more about the students? Or you will be able to know about the student, more about the student maybe in the second year? When you will know about the student, their character, their level of learning, second year. Thank you, Piyush sir. How do you know about it? You know, first on the day one, we don't know anything about the student, right? Like today, Adeline ma'am was hosting the event. Okay, so now when an event or any faculty, when you're going to host the event, you know this student. Okay, this student is good for hospitality. This student, okay, he's good for he's good in comparing. He can lead it. He can organize things. He can coordinate. He can speak with people. So when the students come to second and third year, okay, yeah, if how much you interact, yeah, in the next few months, how much as a faculty you interact with the students, within 6 to 7 months you will know, maybe within a 1 month you know something about the student. To know more about the student, their learning ability, how do they react, are they so truthful, are they not truthful, okay, with all your experiences you will be knowing it. But in order to predict it, you need a historical data. You learn from it. You learn from the student how you have a relationship, how do you speak with the student, how they respond. You find patterns and you generate accurate prediction. The same way you are going to trying to use it in the machine learning model. Okay, so what do you want to know? You need to find, first thing I said, we are going to work on with that. You need to use the historical data. You need to learn patterns from it, learn from the data. You have to learn the pattern of the data. I want you to underline this word, or if you're taking notes, make a writing, learning the data patterns, understanding the data patterns. That is what is more important, and you generate predictions. That is the most important thing. And after that, you find correlations between the patterns, okay, and association of symptoms. Say, for example, if we want to predict that a person is infected with the diabetics, what parameters is needed? Generally, you need not be a doctor also, right? You can unmute and say, or you can put your answers on chat. If you want to detect a person is infected with diabetes, are you able to hear me? Yeah, the sugar level. Thank you. The insulin level. Thank you, Varundaran sir. So the blood sugar level, the insulin sugar level, different parameters, even as a normal, not being a doctor, we know about it, right? So you have to find what are the patterns there, what are the data columns that are correlated with the target, what we want to predict. Okay, correlations, association of symptoms. You said, right, what are the symptoms you have? If suppose if it is COVID, we have a cold, or the taste smell goes. Okay, even I got infected with COVID in the month April 2021. By the grace of God, we were recovered. During the COVID, there was no taste, no smell. Okay, so it finds the habits, the disease, and makes meaningful prediction. So predictive analytics plays an important role in improving the patient care. Okay, so we would have not experienced doctor treating us virtually through a camera or through a video call. It so happened during COVID season, most of us, when we were not able to travel out, meet doctors, we had. So this predictive analytics domain has been working on a wide range of extent for more than 5 years. Very recent, it has been 4 years, but more rapidly it is going on for the past 5 years. Okay, so it improves the patient care. How can you take care of the patient? The chronic disease management. One such example is COVID, and increasing the efficiency of supply chain and paramedical. So if there is, we are now hunting for what? We are now hunting for what in medical field? Yes, answers or chat, or you can unmute. Yes, thank you, Ramashankar Singh, sir. Yes. We are hunting for vaccinations, right? Vaccinations. Thank you, Shwati Kannan, ma'am. Okay. We are very hunting for. So when you have a predictive, so when we know the pattern, so this month, this many people are getting infected. They're taking up vaccination. Sorry, with the total number of population, the next month we can predict this much of medicines we need or the vaccinations we need. Okay, for that predictive analytics plays a vital role. All right, so population health management is becoming a very increasing popular topic in predictive analytics. How are we going to manage it? Okay, now this time we see we are experiencing it. It is a data driven process focusing on prevention that is prevalent in the society. Okay, with data science, hospitals can predict the deterioration in patients' health, and also they could provide measures and start an early treatment. Okay, which will reduce the risk of the patient. That is what predominantly it is used in predictive analytics. So, if the patterns of the infection is like, then the next when we give the values into it, if we give the values into the data set, and the prediction model will predict whether the next 3 months or next 6 months whether the infection rate will increase, how it could be treated. Okay, it cannot replace doctors, but this can work with lakhs of data, learn the data patterns from it, and it will be able to do a prediction about the health care of a patient. Okay, so it plays a vital role. I told about it. So IIT Mandi, right? So in October 4, 2021, okay, the artificial intelligence based monitoring application for COVID-19 they've released. Okay, in addition to the quarantine management, this application also serves as an unreachable mobile platform for normal users. How many of you have seen this? Yeah, I just took this from the newspaper. Okay, IIT Mandi. Okay, they have developed an artificial intelligence based monitoring application. So when you have a data set, when you're going to develop it, you can make it either into a web application or into the mobile application. If there is time, maybe today or tomorrow, I'll show you the development of web application. Okay, where and all you can use it in data science and healthcare. Okay, listen to the entire talk carefully. At the end of this talk, we are going to play a live quiz, just simple questions. We are going to see who will be the winner, who's going to answer fast, and you will be the winners. Okay, at the end of the session, we have a live quiz. Okay, so data care and healthcare. Data science in healthcare, where and all you can use. You can work with and genetics. Okay, what are the prevalent vaccinations that we use in India? There are 2 vaccinations most of us we use in India. What are the vaccinations? You can unmute and speak. Yeah, Covishield. And there is Covaxin, right? So, in which one of the vaccination is a programmable vaccination? Do you know? One is a programmed vaccination. Which one is a programmed vaccination? Okay, Covishield. So here here we have a vaccination which is programmable with the DNA. Okay, so here you see the data science and healthcare. The best application is genetics, genomics with the DNA, drug discovery. So if the patterns of disease are like that, if you want to, you all know when we get a fever, what tablet we use, what ingredient will be there in the tablet, what is a component that will be there in the tablet. You can unmute and speak also. You're allowed to unmute. It's paracetamol. Okay, paracetamol. You know about it. So, when a person is infected with fever, you need to treat it with paracetamol. Giving the different symptoms, what are the different drugs that could be used? Those data science could be programmed for a new drug discovery. All right, for virtual assistants that I said, right? Doctors, they started using phone calls, or the video calls for treatment, the data management. If you take for example in government hospitals, how many patients are treated? Okay, what is a healthcare? Sometimes it's overflowing. We are all seeing it, right? So, and also for predictive analytics, it could be used. And image analysis, a wide range of applications could be done. Okay, it cannot replace doctors, but it can process data faster than a human. Okay, faster than humans. Okay, the next thing, what is the need of data science in healthcare industry? Okay, so this is the topic that we are seeing. What I'm highlighting, can you see here? Predictive analytics in healthcare is one of the most important data science industry. And also we can think of monitoring patient health, all right, drug discovery, okay, data science for genomics, data science for imaging, for virtual assistants, and a lot of anybody use the app for their track, right? PCM for fever only, but under as if taken extensive, very clear definition. Ramashankar Singh sir. All right, okay. So tracking, right? They give some kind of what do I say, application, and then they are tracking with the location. All right. Providers who use advanced predictive model are tackling the following clinical challenges. Okay, 27% are predicting readmissions, 18% are predicting patient deterioration, 27% are predicting SIPs, 10% are general patient health, and 18% are finalizing. So this I said to you, right? They started this research. Just it has been into the field for a long time, but rapidly it started following for the past 5 years. Okay, so yesterday also you should have heard about it, right? The descriptive analytics, okay, the diagnostic analytics, the predictive analytics, and prospective analytics. So this is this you can see here. It's a insight and foresight. Okay, so what is descriptive analytics? How many patients went to hospital last week? Diagnosis, why did these patients go to hospital? Predictive, which patient will go to hospital the next week? Prospective, these patients should get extra treatment to prevent hospitalization. This is just in simple words, but we are going to work with data sets. Okay, descriptive, you need to know about the data. Okay, so when we have a data, what are the patterns? As I take the diabetics, okay, if these are the patterns of data, then we say the patient is diabetics. If these are the patterns of the data, then the patient is not. If the sugar level is below, then they are not diabetics. If the sugar level is above, then they are a diabetic patient. So how many patients? Next, why this patient, how they became diabetic, and how to prevent them, and how to protect all their organs. Okay, so descriptive analytics is much needed. You need to understand the data. Okay, and we'll be working diagnostic. Why? What are the patterns that influences more? That is what we work in correlation. And predictive, what can be done to prevent it? And furthermore, how to do it. Okay, so this is the structure. You can use it for any kind of applications. All right. So able to understand the introduction of data science for healthcare? Yes, no? Answers on chat? Okay. Okay. Thank you all for your good responses. Okay. Thank you, sir. So next we are going to see, this is about data science and healthcare. So today and tomorrow session, we are focusing on machine learning, and further in other days, we are going to deal with deep learning also. Both machine learning and deep learning, okay, they discover patterns in data. That's what I told you in the first slide itself, right? So you need to learn the data patterns. Okay, when we communicate, when we build a friendship with people, then we, as humans, we know what a friend likes, what a friend doesn't like, not on the first day of our introduction. As the friendship gets building up day by day, year by year. All right, so even both machine learning and deep learning, both of them, okay, both machine learning, deep learning, their heart is, the main core part is to discover patterns in data. Okay, to discover patterns in data. But how they involve, dramatically, they use different techniques. Able to understand? So when you take machine learning or you're going to take deep learning, in both techniques, you are going to discover the patterns of data. Okay. So both are same, but they were dramatically different. For both, they are going to learn patterns from the data. All right. So how are they different? Yes, they are forms of artificial intelligence. First we had artificial intelligence, then we had machine learning, then deep learning. So deep learning is a specific kind of machine learning. I repeat it, deep learning is a specific kind of machine learning. So they both, when you take machine learning and deep learning, they start with training set and testing set. So you'll be training. Your data set will be splitting into two. One is a training set, other is a testing set. And then we develop a model with the trained data set. Then we feed our data into a testing data, and then the value that is given out of the testing model is the predicted value. Okay, and after that we can go in for optimization, for hyperparameter tuning and all such things. Okay, and then we find which model fits the best. Okay, so machine learning and deep learning are both the forms of artificial intelligence. Okay, first artificial, the subset is machine learning. The subset of machine learning is deep learning. All right. But in deep here, when you take a feature and then you go in for classification, the feature extraction, then you go for classification. But when you take deep learning, feature extraction and classification, they go hand on hand. Okay, they go hand on hand. That is why the accuracy is different, and deep learning is totally built upon the neural networks. Okay, the neural networks. So when you compare machine learning with deep learning, okay, deep learning accuracy is more far in comparison with machine learning. All right. Okay. Then what are the 4 steps when you want to develop a machine learning model? First, you need to prepare a data. Today, we are going to see about a heart disease. Okay, heart disease data set. Okay, we need to prepare a data. Whenever you are going to take a data set, it should be a benchmark data set. Okay, there are a lot of repositories wherein you get benchmark data set. You should have a very keen interest of developing. Say, for example, if you're going to use your own data set, there is a highest possibility you can pattern your data set according to your target. Okay, when you take a benchmark data set, they have with all combinations. So when you develop an algorithm to authenticate that this new algorithm will work for all kind of situations or all kind of variables, the minimum, the maximum, with all variations, that is what we need to use benchmark data set. All right. So how do you prepare a data? The second is the feature engineering. What are the needed features that you're going to take it from the data? There are 2 things. One is called feature extraction and another is feature selection. Feature selection, say for example, when you have your college database, what are the attributes you'll have in the college database? What are the columns? You're able to hear me? Yes? Yeah, student name. Yeah, student register number, marks. Then only these things you'll have in a college database of a student. Phone number, then the address, right? Their blood group, their email ID, their WhatsApp number, their Aadhaar number, yes, the gender, okay, the course details, everything about a child you need. Okay. So when supposingly if you are given your task, the problem definition, say for example, imagine this scenario. This set of 30 students have joined your course. They've completed the internal 1, internal 2 and internal 3. They're preparing for the models. And you are, as a faculty, as a data scientist, you are given a task. Okay, before, how many of the students will pass in the exam? How many of the students you need to focus more? How many of them will fail? Okay, so out of all these column values that you column names you have given, what are the necessary columns that you will take to develop this model? Your objective is this out of this 30 set of students, how many will pass? how many need extra training to pass, and how many will fail. Out of these columns on your college database, what are the columns will you choose? You can give your answers on chat. Name, mark, average, the register number. Okay, the result. Only these things. Now, nobody you posted the address, the Aadhaar number, the blood group or gender. We need a student ID. We need what are the marks the students have got. And then we have not developed the model. We are going to develop the model. First, we are preparing the data. We are in the first step of preparing the data. So when you take a data set, you have all the data. Out of that, in feature engineering, I gave you a scenario, okay, in which you are going to find the academic performance of the student. So you all gave only certain columns, right? This is called feature selection. You know the target, and from the entire data set, you are taking it. In some data sets, you are not able to understand the column, then you need to go on for feature extraction. There are various algorithms. You feed in your data, you give your target. After the algorithm or after the correlation, there are different methods to do it. Then you get the values, and only those features of importance will be taken to develop your data model. So in feature engineering, there are two parts. One is feature selection, the other is feature extraction. Is it clear? Okay, yes, no, no, yes. And out of these important features, you're going to, some data set you get it will have high correlation with the target, which means all the data columns are needed. Okay, say for example, if you're going to have 70 columns, imagine your prediction value itself will come down. So when the number of columns are more, then you definitely need to do a feature selection or feature extraction. All right. Okay. So in feature selection, you know the target and you're selecting the needed features. The example that I've given is the student's academic performance. Entire data set you have, say, register number, name of the student, the mark of the student, parents' name, parents' occupation, parents' annual income, Aadhaar number, the address, the gender, everything along with the marks you have. That's the entire data set. And in feature engineering, you have given an objective to find the academics of the student. So you take only the serial number of the student, the marks you have taken in first internal, second internal, and third internal. You have not developed the model, just you are taking only the selected, and then you'll be able to do it. Okay. In feature extraction, say for example, you are going to have a data set of of 70 columns. If you more number of columns, then the prediction value will not be there. The first objective is to find what are the features it is of importance. Only the important features will be taken. For that to incorporate your feature extraction, different algorithms, different optimization algorithms, and different inbuilt algorithms are there, from which it will extract it. Say a very simple example of feature extraction, if you're going to find the correlation with the target. Whenever the correlation value becomes negative, you are going to drop that columns. Only once above it is 0.1 or 0.4, then you'll be able to take it. Okay. Able to understand about feature extraction and feature selection. Feature selection, you do it. You don't use any algorithm. In feature extraction, you have an algorithm which will tell you which are the important features. I repeat it, in feature extraction, you are going to select what are the columns you need. In feature extraction, you have an optimization algorithm. It could be a particle swarm optimization. It could be an ant colony optimization, from which the algorithm will say what are the important features for this particular target, for this particular prediction model. Okay. Yeah, ranking also could be done. Yes, there are thousands and thousands of methods to do it. Okay. And then with that, you're going to model your data with your machine learning algorithm. Once you do it, you are going to work on with your performance measure. Okay, performance measure, we are going to see about accuracy, how accuracy model, the precision, the recall, F1 score, okay, the confusion matrix. That all these are, there are not only this, there are still more performance measures. What is the best that we could see today? We'll be seeing it today. Okay, say for example, you're going to take a disease data set. This is the basic step. Okay, this is the basic step that you will be following it. Okay, you take a data set. So today, what data set we are going to take after the theory part? I told you, let me see how many of you have listened to it. What data set? Yes, thank you, Ranal sir. Thank you. You are going to take about heart disease data set. So heart disease data set, we are going to split a data set into training data and testing data. Okay. In training data, we'll be training it with 3 algorithms. We learn the model. Then we give our testing data set into it, and it is going to predict whether the particular patient is going to have a disease or not. Very, very simple architecture. Any disease. Okay. So instead of disease, if you change to be climatic prediction, then here you change the word as climate, split the data into training and testing. Not only this algorithm, any set of algorithms, and I will tell you what algorithm you use for what data set you should use. That mapping I will tell you. All right. Then you learn the model, you give only the training data set, and then you predict whether the person is going to have a disease or not. Okay, I've arranged the slides accordingly because our topic is predictive healthcare analytics. Okay. Okay. So, can you see my screen? Yes. Okay. Thank you. So now we are going to start. I told you the difference between machine learning and deep learning. And today and tomorrow we are going to work with machine learning. All right, we are going to work with machine learning. And in that, today we are going to see about classification, and tomorrow we are going to see about clustering. Okay, as a data scientist, yesterday sir should have spoken to you about what is a data scientist, data analyst, what is the fundamentals of data science. Okay, so there are majorly four things. Okay, there are majorly 4 parts in machine learning algorithm. One is classification, clustering, dimensionality reduction, and regression. Basically, these 3 are the most important: classification, clustering, and regression. Okay, I'll just tell you the roadmap. Okay, the basic part is classification, clustering, regression, and dimensionality. First, we'll see the introduction about what is classification, what is clustering, regression, and dimensionality detection, and then we come into this mapping. Okay. Okay, what is classification? When do you this is the most challenging task. You need to know when you should do a classification algorithm, when you should do a clustering algorithm, and then when for regression. Okay, this is more needed. Classification to identify which category an object belongs to. It could be a spam detection. You want to recognize the image. Now, the beautiful research, people with mask or without mask. Before we had face recognition with mask and without mask. Okay. Can one of you give an example of classification? For a classification domain, the particular patient is going to have a disease or not. Okay, that example. Whether the student will pass or fail, you have a target. Yes. Win or loss, whether the sales is going to win or loss. Okay, hot or cold. Okay, pass or fail. Yes, very good. Any more? Okay, so in classification, you're going to find whether this particular category positive or negative. Okay, very nice. So for these kind of applications, you use classification algorithm to find which category an object belongs to. Listen carefully. All classification algorithm will have a data set of features and target. You will have a feature and separately you'll have a target. Okay. Whenever you have a classification, you're going to develop a classification algorithm, definitely there will be a target value. What are the target values? The target values are those according to the application, what you have given, male, female. Okay. Suitable for, yeah, it's suitable for, if you, a lot of things are a machine learning algorithm and deep learning are working in agriculture also. Whether it is suitable for cultivation or not. Fit the sentiment and analysis, whether it is positive analysis or negative analysis. Okay. So this is your target. When you're going to listen carefully, whenever you're going to have a data set with a target, which is yes or no, it could be whatever you have given us binary classifiers. It could be even multi-classifiers. Say, for example, say a heart disease. Okay, this is the whether the patient is going to have heart disease or not. Then you are going to develop a binary classifier, or you're going to see the level. There are 3 levels of heart disease. Okay, one is no disease, one is level 1 of the disease, second is the more severe, and third is the severity of the disease, level 1, level 2, level 3. In that, if you're going to have target like that, then you need to develop a multi-class classifier, multi-class classifier. So understand clearly, whenever you have a data set with the target, then it is a classification algorithm. Yes, you're able to understand? Okay, next we'll go into clustering. Okay, so tomorrow we are going to see about this. All right, so automatic grouping of similar objects into sets. Okay, the customer segmentation. When a different customer comes to, when you keep going to the same shop again and again, what would be your experience? What is your experience of going to a new shop or to a shop that you frequently visited for shopping? One of you can unmute. You are not allowed to unmute. I don't know. It's unsupervised. We'll come into supervised and unsupervised. Okay, okay. What is your experience? What would be your experience? You go to a new shop, you're a new customer, or you go to a shop where you frequently go to it. What would be your personal experience? I'm not coming into data science or nothing. Just a real life time example. What would be your experience? Okay, when you go to a new shop, the customer will not know more about you, what you would like to have. But when you go to a new, we can easily find the items located with the old experience. Unknown shop, we don't know about the items. And more important, when you go to a shop, the person will know, sir, this is the product you always like, sir. The new product has come, sir. You can see to it, sir. They would have, and they know what range. Say, for example, you're going to shop for 10 years. Or get to the same shop, they definitely know what is your budget. So they will show items only according to your budget. Able to understand? So they know according to each customer, they have learned the patterns of the data. They have learned about your data pattern. How, what you like. Say, for example, if I go for a shopping, when I go to a particular shop, they know this color of saree you like, because the person knows. But if you are new, you do not. Even if they knew, according to the data set, we'll be able to segment the customers. Okay, so those kind of application and grouping experiment outcome. What would be the outcome of this? Okay, for those kind of applications, we can go in for clustering. Okay, first let's understand about classification and now clustering. For these are the algorithms that are used. Okay, where in clustering, listen carefully, you will not have a target. In classification, what did I say? You will have a target variable. But clustering, you will not have a target variable. Okay, you will not have a target variable. Okay. And the next thing we are going to see is regression, where there is a continuous valued attribute. Okay, it could be drug response or stock prices. Okay, there are different regressions algorithms available. The final module is dimension reduction. I said, right, reducing the number of random variables to consider. So to visualize, say for example, if I have 70 columns, if I visualize also, I'm not going to use it. For that, I can go for PCA, feature selection, and non-negative matrix. Okay. So these are the 4 major things in machine learning algorithm. To start off with, you start your data set. Okay. When you want to work, you have to work with huge data. Okay. When you're going to work with the data set, the first of all, most important thing in machine learning, your data set should be at least more than 50 samples, 50 rows. Okay, more than the set of data. More than. If it is, see, the first step, you're going to find whether it is more than 50 samples. No means you go and get more data and come. Whenever you take benchmark data, I have experience even with 20 lakhs of data, in microseconds, you'll be able to get your results. Okay, in microsecond also, you'll be able to get your results. Okay. So your first constraint when you want to develop a machine learning model, it should be more than 50 data. Then you're going to find whether you're going to predict a category. If you're going to predict a category, Yes, then do you have a labeled data? Yes, then you go for classification. And also if the values are less than 100K, then you go for linear SVCE. It's not working, then you go for naive-Bayes. If your values are more than 100K, then you go for SGD. Okay. If text data, you go for naive-Bayes. Not text data, you go for K-neighbor classifier and SVC. If it is not working, then you go for SVC and Pandas. If you don't have labeled data, that is what we'll be seeing about supervised learning and unsupervised learning. Okay. If you're not going to have a labeled data, you don't know number of categories known. Okay. If you know the number of categories and it is less than, then you go for mini batch k-means. If it is more, if it is less, you go for this. If the values are more than 10K, you go for k-means. If that is not working, then you go for spectral clustering. Okay. If you don't know what is the number of categories, okay, and if the values are less, you go for main shift, or more, you need to go on for another kind. Okay. And here, if you're going to predict a model, if you're going to predict a category, no. I told, right, for regression, it's continuous variable. You're going to predict a quantity and the values are less than 100K. Yes, then few features should be selected. Yes, you go for lasso regression or elastic. No, you go for ridge regression. No, if the values are nil, then you go for SGD regression. Okay. If you're not going to predict a value, you're just looking for it. Yes, then you go in for random, where you go in for dimensional detection when the number of values are more. And again, if it is yes, random PCA, if it is not working less than 10, then you go for I. No, then you go for kernel optimization. So this is the map that you need to really work it on. Okay. For today's, yeah. Today, we are going to see about the classification. The data set should be more than 100. You are going to predict a category. Yes, I'm going to have a labeled data today. Tomorrow, we are going to have an unlabeled data. Okay. So here today, we're going to see about the classification that is used to predict a discrete class, X, Y. Okay. And basically, here you have input variables to a class which belongs to the classification model on data set that's already labeled. Okay. Labeled data is used to train a classifier. So how does it going to perform? Okay. So I said again, classification is divided into other category: binary classification, multi-classification, or multi-label classification. Okay. We'll just see into this example today. Okay, we are going to develop a machine learning classification development model. First step, you need to have a benchmark data set. You need to do an exploratory data analysis. You need to do the data curation. Third step, future engineering, developing a model, and analyzing the performance metrics. Okay, these are the steps. How many of you have already worked in data science? On machine learning, yes or no? Yes, thank you, Piyush sir. Thank you. If it is yes, you can type yes. No, you can type no. Some of you are new, some of you are doing. No, yes. Okay, yes, along with IoT. Thank you, Ambika ma'am. Nice to hear. A lot of applications we have. Yes, no. So you have got multiple different comments. This is the predicting target, right? So here even we are doing a data analysis. Okay, without machine but human prediction. How many of you know? How many? I could say like 50%. Okay. So then I could take my talk according to people who know about it and also to people who don't know about it. Okay. So data set is the starting point in your journey of machine learning model. How much minimum? How many rows you should have? How many data you should have? You think, right? The speaker is always asking questions. Okay. From the mapping, I told you how many minimum data set you should have to develop a machine learning model. Thank you, Surya ma'am. Thank you. So all of you are listening carefully. So a data set is a starting point. Okay, it's just you can simply put your data set as essentially as an MNN matrix. Okay. MNN matrix, okay, where M represents the column and N represents the rows. Okay, so here I'm going to take a data set. Okay, I'm going to take a data set, M columns. Okay, M as 0. And I'm going to split my columns into two things. One is my feature, the next is my class label. Listen carefully. My data set will have rows and columns. Columns will be labeled completely. It is a labeled data set for classification model when you want to develop a class. In that column, listen carefully, I'm going to split into two, the features and the class label. Okay, features will be all the columns and the class label would be my target value. You have given me the answer, win or loss, disease present or not, pass or fail. Okay, only one funny prediction I got, it's gender, male or female. Okay, so something you're going to predict it according to whether it is going to rain or it is not going to rain. Okay, only that column will be taken as a class label. You have a set of columns. You're going to split your columns into your features and your target. X here in this picture, X denotes your features, where it will not have the target, Y will have the target. These features are independent variable, but this is a dependent variable. Can you see here? This is your data set. Samples simply for the structure. A set of rows, set of columns, X1, X2, X3, X4 are all independent. Their features and Y is your target. This is a class label. Okay. Now, in machine learning, you are going to have two kinds of learning. One is a supervised learning and unsupervised learning. Today, we are going to learn about supervised learning. Tomorrow, we are going to learn about unsupervised learning. Okay. Here, when you see supervised learning, you develop a predictive model based on both input and output data. You have a target variable, then you go in for supervised, in which today we are going to see about classification. Throughout the sessions, you are going to learn about regressions also. Unsupervised learning, what in unsupervised learning, which variable you will not have? You will not have your target variable. Understanding? You will not have a target variable. You will group and interpret based on the input data. So that is clustering. Okay, supervised learning comes under, see, when a student comes to college, learns under a professor, and you develop a model, this student will pass or fail. When you learn in distance method, or what you say is, it is correspondence method, that is an unsupervised learning example of it. Okay, so I give a set of input data. What is it? It's an apple. I have a supervisor. I have a label. So I'm going to split my training. This is my training, is my features, and Y is my target. What is my target? It is an apple. Then I'm going to develop an algorithm, process it. While testing, while training, I'm giving a red apple. So it takes a structure of it, everything of it. When I'm giving a green apple, the color is only changing, but also my model will say it is an apple. Okay, you have a supervised. But in unsupervised, I'm not giving only apple. I'm giving to apple, apple, banana, mango. You don't know what is your target. Here you know what is your target. What is your desired output here? In supervised learning, the output is apple. If these features are there, then it is an apple. Okay. If these features are there, then the person is infected. If these features are there, the person is not infected. X features is totally an independent. Y is a target. All right. Okay, I don't know anything about the output in unsupervised learning. I have an interpretation. It learns the patterns of each and every attributes, and then it processes it. See, in output, it's giving it is doing a 3 clustering and set of apples, bananas, and mangoes. Okay, so input, whenever it is labeled, it is a supervised learning. The input data is unlabeled, it is unsupervised learning. Users training data set. Here, there you split your data set in classification. What you're going to work, you are going to split your data set into training set and testing set. Here, you just input your data set. It is used for prediction. Where do you use that is also very important. Being a machine data scientist, or you're doing a machine, for what you're going to use. This is used for prediction. In unsupervised learning, it is used for analysis. Okay, here you can use for classification, regression. Here you can use for clustering, density estimation, and dimensionality reduction. Able to understand clustering, supervised, unsupervised, classification and clustering, where it works. Data set that is used for supervised learning can also perform regression, because you have X and Y. But when you have your unsupervised learning, you have only your X, you don't have a target. So before I go into it, in classification algorithm, you have a data set which has a target. When you come for clustering, you have a data set where you don't have a target. And in clustering, classification, you have a labeled data set. In clustering, you have an unlabeled data set. And classification is used for prediction. Clustering is used for analysis. Is it clear about classification and clustering? Because today we're going to see about classification, tomorrow clustering. Thank you, Nirupam ma'am. Thank you, Surya ma'am. I hope all 84 of you are there with me, leaving me. Okay, 83. All right. You're able to understand till now, clear? Thank you, Gomati ma'am. Thank you, Gom. The challenge in taking online classes is we don't know whether the participants are with us, whether they're able to understand. That's what I asked several questions. All right. Okay. Now, thank you, Varanidharan sir. Very clear. Exploratory data analysis, the first step. Okay, it's performed to understand more about it. Okay, it's called eyeballing of data. You can have different kinds of visualization. Beautiful visualization, different kinds of graphs. Here we have violin graph, the box plot, the box and plot, the heat maps. Okay, to do this, the technology that you're going to use, the tool is today we're going to see about Pandas. Why Python for data analysis library? Pandas is very fast, powerful, and very excellent to do for data analysis. All kinds of analysis you can do. You can take a data set. Today we're going to take a data set. Okay, once I take a data set, and then when I load the data set onto the Pandas, the data type will be converted into data frame. Say, for example, my input is an Excel file. I take an Excel file, benchmark data set, put it onto my Pandas, it converts to data frame. My input is a CSV file. CSV stands for comma separated values. TSV, it stands for tab separated values. If I take any TSV, load it into Pandas, the data set will be converted into a Pandas type. Say, for example, you work in big data analytics, Hadoop. Anybody here? You work with Hadoop distributed file system? I worked a lot. Okay, single node Hadoop cluster. Anybody here works in Hadoop? Okay. Okay, so even if you have a Hadoop distributed file system, HDF file, you can load it. SAS file, yes, you can load it. Whatever is your data type, once you load it into Pandas, listen carefully, your data type will be converted into data frame. I repeated, any data set. Thank you, Varanidharan sir. Hadoop and Apache Spark, a beautiful tool to work on with. Okay, so whenever you take a data set and load into Pandas, the data type, once it is loaded into Pandas, it is called as data frame. Okay, data frame. Okay, what you can do in Pandas? What you can manipulate data sets. You can know the features. I said data frames. You can rank it. I don't know. I remember somebody posting it on the ranking of data. And one more important, if you're taking notes, if you're listening to it, write this point and keep. Even if there is one missing values, you cannot develop a machine learning model. You know, say for example, if you're going to have 20 lakhs of data, you cannot go manually and find it out, right? Whether you're going to have a missing value. Finding out missing values, whether there is missing numbers, then we use Pandas to do it. Then we have to work on with, there are different methods to remove the missing values, or to give it could be a standard deviation value or mean value or mode value, different things could be done. And if you have two data frames, we need to concatenate it. Then you can concatenate a data frame. Because I'm working with the PhD scholars. I train them and they develop it for them. Some scholars, they come, ma'am, we want to work with raw data set. Once they take a raw data set, we need to take it up. We have to check for missing values. Sometimes same data set in 3-4 locations, but having the same column. We need to concatenate it. We need to find the missing values. Then how to replace the missing values. You can take a standard deviation or mean or median, and then doing it and filtering it, everything, filtering, slicing, okay, group by function, describing a data set, all these different panels, everything you can do it in Pandas. Even in Pandas itself, there is a huge things to work on with. Only with why convert data to data frame? When you want to work your data set into, when you want to do an exploratory analysis using Pandas, you will be hosting all the data into, in this today's tutorial, what we are going to see, hosting a data set into Pandas, wherein Pandas takes the data type as you cannot, with raw data, you will not be able to work on with. So what are the attributes in data frame? Okay, you can find the data type, you can find how many columns are there, how many axes are there. If you're going to work with multi-dimensional data, finding the number of dimension, the size, shape and value. But listen carefully here. I told when you take a CSV, when you host it into the Pandas, the structure becomes data frame. But the values inside the data frame will be of type NumPy array. Yesterday, sir would have spoken about NumPy array, I believe. Okay, the values inside your data frame is NumPy array. Okay, but your entire Pandas data type is data frame. Okay, whenever you don't have this open and close parenthesis here, then it is an attribute. Okay, so these are the common attributes in data Python data frames. Sorry, Pandas. Here, when you have a column, okay, head of, tail of, describe of, min of, max of, mean of, standard deviation, drop NA. This is also one method to drop all the records with missing values. There are different algorithms, there are techniques to work on with missing numbers. Okay, so here, when you have an open and closed parenthesis, listen, understand clearly it is a data frame method. When you don't have just only that, then it is data frame attributes. Okay. For data visualization, these are the different, I said, right, for missing numbers, you cannot go, you can also visualize how many missing numbers you have in your data set. Okay, so Matplotlib for visualization, Seaborn, ggplot, bokeh plot, okay, pyglaal, Leather, Gleam, Geoplotly, Plotly, and today we'll be using these two, Matplotlib and Seaborn. And what are the different plots you can have? You can have a disk plot, which is a histogram, the bar plot, violin plot, joint plot, regression plot, pair plot, box plot, swarm plot. These are for categorical values and factor plot. Okay. So when you want to develop, we need to define the problem, benchmark data set, do an exploratory data analysis using NumPy, Pandas, Matplotlib, check for missing values. Very, very, very important. And if you have a categorical value, if you have a strings, you need to convert into numerical values. Then do the feature engineering, feature extraction or feature selection. Then you need to split the data set into training and testing. Since it is classification, your training will have a feature on target X and Y. Testing also will have a feature on target X and Y. Then we'll build a model. Then we'll build a model using the different algorithms. And then we need to find the performance metrics. These are the steps, 9 steps. Okay. So now we are going to take a scenario. Okay. I'm going to take a data set from UCI, pre-process it, normalize it, splitting it, feature extraction, selection, splitting it, applying the model, doing the labels, and computing the class confusion matrix. This is what we are going to do. First, I need to pre-process it, do the EDA. Then I'm going to do the splitting and training and splitting, applying the model, and predicting it. Imagine that you've just hired as a data scientist. Okay, and they've given all the data of cardiologists, what they have measured. And your objective is to find whether certain patients have heart disease or not. So this is a problem definition. That's what first step I told, right? First step is you have to define a problem. Okay, now everybody imagine yourself, sit yourself as you are the data scientist and you're employed in a hospital, and they have given you the data, a cardiologist have given you a data set to develop a machine learning model. To find a new patient comes, they tell all the symptoms and you click the predict, then it says the patient is a heart patient or not a heart patient. Okay, so whether the patient should be diagnosed, today we are going to work with binary classifier. Okay, we are going to work with binary classifier. If it is 1, if the patient is diagnosed with heart disease, then my target value, remember I told X and Y. X is independent, Y is my class label, which is 1 means the patient has a heart disease. If it is 0, then the patient is not a heart disease. Okay, we are going to find what are the different trends, what is the correlation of our data. So this is our goal. So this is the data set that we are going to work today. So what are the attributes? It has 13 attributes. So what is the target? For positive is 1. If the patient is not a heart patient, then it is 0. That is my Y. What are my X? X are my features, right? So age, sex, it's a binary. Can you say binary means the value is 0 or 1? Chest pain. There are 4 values. It's an ordinal value. Can you see? It's an ordinal. Value is 1, it is typical engineer. It is 2, atypical, non-engineer. Okay, asymptomatic. All right. If it is stressed, BPSC, which means you need to understand the data very clearly. First, you need to define the problem, and for the problem, what data set you need to understand. Okay, resting, it is called resting blood pressure. Okay, call, this column says serum cholesterol. FBS, fasting blood sugar, if it is greater than 120, 1 is true, 0 is false. It's a binary value again. Resting ECG, resting electrocardiographic value 0, 1, 2. Thalach, okay, it's maximum heart rate. Receive, it's a continuous different variables. Hash means it is different variables. Exam, exercise induced engineer, it's binary X, 1 or 0. There's no old peak ST, depression induced by the exercise relative to rest. Okay, slope, the peak of ST segment, the peak of the ST segment. Value 1 is upsloping, value 2 is flat, value 3 is downsloping. Okay, CA. Okay, CA stands for majority vessel walls. Okay, 0, 1, 2, 3, it's ordinal, and maximum heart rate achieved. 3 is normal. If it is 6, there is a fixed defect, and 7 is a reversible defect. Okay, so these are the different columns. How many columns we have? 13 columns we have, and totally we'll have 14. One is a target. One is a target. When you see here, can you see here hash? One hash, can you see? 2, 3, 4, 5. Whenever it is hash, it's a continuous variables, which is a quantitative. Ordinal means it is categorical, it is 0, 1, 2, 3. Okay. If it is binary data, then it is 0 or 1. Can you see here binary? What are the 3 types of data in this data set we have? One is continuous, one is binary, other is ordinal or categorical. Okay. Yes. You're all there with me. Okay. You're able to understand the data set? Thank you, Nirupama. Okay. Now coming into, I'm just showing you the same data set. Thank you. Thank you, Adeline, ma'am. Thank you. Okay. So age, it's numerical. It's an integer data type. Sex, one is male. It's a categorical integer. Chest pain is categorical integer. Resting is numerical. Serum is numerical. Fast is categorical. And rest ECG is categorical, numerical. Okay, these things we need to understand before we start working with the data set. Okay. So data wrangling, what is data wrangling or data curation is cleaning of data sets. Okay. Sometimes you get a pre-processed cleaned data set. Then you don't have to work about it. Okay. You can make multiple predictions. Depends on the algorithm that you make, Ambika. You can also make combinations. That is, I skipped off that slide. You can also do multi-label or multi-class. Okay. Thank you. So data wrangling is more important. Today I've taken a data set which is almost fully pre-processed. Okay. So there are different things that we can process it. Okay. And we are going to import NumPy as NP. What is NumPy? It's for numerical Python. Pandas, it's used for analysis. Matplotlib is PLT. Seaborn, both are for visualization. Okay. Now, moving on to our how many of you are working with Colab? Data wrangling means we are cleaning the data. Okay. So if you are using Gmail, I know everybody will use Gmail. If you go and open another tab as colab.research.google.com, you will be able to open up. Okay. You will be able to open up. And then click on File, New Notebook. I don't know how many of you are going to try. How many of you are going to try? You can type you're doing, or somebody, you will be even listening. Trying. Thank you, Surya ma'am. Okay, you can, I'll just zoom it a little bigger. Okay, you're trying. Okay, you can import NumPy as NP, Pandas as PD, Matplotlib.pyplot as PLT. Okay, those are trying. So what did I say? It's for regular exploratory. Whenever you want to do a exploratory data analysis, all right. Whenever you want to do a exploratory data analysis, you want to plot libraries. These four are the needed columns. These are needed Python packages. I have to learn by trying. No problem. You could just click on when you are using a system. Open a new tab. I hope my screen is seen. This is your Gmail. You open a new tab and just type colab.research.google.com. Okay. Yes. Okay. So I've imported the needed exploratory data analysis. Okay. And then I'm going to mount my Google Drive. I have my data set. What data set I said? Hard data set. Okay. I've already worked it for another thing for deep learning, but today's topic we are working with. So I have this hard data set inside my Google Drive. Can you see it? Can you see my Google Drive? Yes. So I have my hard data set. Okay. So how many columns we have? I said we have 14 columns. We have one target and others are normal data. CSV is comma separated values. The reason behind why we go for CSV is that even you have got limitations to your Excel number of rows, but here you don't have limitations to your number of rows. Okay, and the file size is also it's looking very small, and this is the data set. Okay. So once you have given import numpy as np, matplotlib as plt, cbon, yes. This is the coding to mount your data set, to mount your Google Drive from google.colab import drive, from google.colab import drive, drive.mount off. So when I'm going to click it on, this is where I run the cell. So when I run the cell, first time, once you're going to use it, you'll get like this. Click it on, click the link. After you type in the code, click the link. Okay. And you should be, I use a lot of emails, so you should be very, very careful. So this is the email ID that I use, Doreen, CIRF@gmail.com. So once I click this link, listen carefully, a new tab will open. Once a new tab open, I have to select the email ID what I've used it for the collab. Do not select another email ID. I know most of you, we use several email IDs every day. One for college, and then when you give that link, click that link, a new page opens. Select the particular Gmail what you are using for collab. Copy this code and then paste it. You are authorizing the collab to use your Google Drive because your data set is on the Google Drive. Okay. So now my data is mounted onto the drive. Wait, I will share the data set with you. Listen for a while. So when I click this folder here, can you see once my drive is mounted, I'll get drive like this. I have lot of collabs because we give training for people and for students, staff, and also the unique thing of my company. I was also into engineering colleges for a decade. Then I started a new thing called faculty internship. The reason behind, when we learn, some courses are not there, but new courses comes and sometimes the faculty ask Every training is hands-on training. You have 20 hours, 40 hours, and for research scholars also, we don't develop, we train them and they develop it. When they have errors, we help them out. Okay. And if there is any requirement, you could contact. Okay. When I click, my data set is here in deep learning healthcare. Okay. Can you see this is my heart data set? So you have to locate where is your data set onto your drive and then click it on and select copy path. After you mount the data set, go to the drive, the location where you have the hard data set. Okay, copy the path. And then come here. Now I'm going to load my data set. So what I've imported, I don't know how many of you are trying, import numpy snp. Whenever I want to use pandas, I will use this aliasing variable. You have one name at home, one name at college, right? The same way here. At NP, whenever I want to use numpy packages, I will use NP. When I want to use pandas, I'm going to use, I told using pandas, you'll be able to take it, right? So I mounted it, all right? And now I'm loading my data. So this is also user defined variable df, which is equal to PD. What is PD? Pandas. What is my data type? What is my type of data? Can you see what is my type of data? It is a CSV. So I'm giving as df is equal to pd.read underscore CSV and I have to paste the path. What path? I've taken it from my drive. So once I paste the path, okay, and then I told you about data frame attributes. Attributes doesn't have columns. Now once I run it, I can see I have 303 rows and 14 columns. 303 rows and 14 columns in this data set. All right. Now, for everyone, I'm going to share this data set. You can see it on your chat and you can get it. Load it onto your Google Drive. Load it onto your Google Drive. I just downloaded and I kept it. Okay, I will download it again. I just downloaded. I'm not able to locate it. Okay, so I'll share this data set. Any doubts till now? Yeah, already I've done it. 356. Yeah, I got it. I've sent it to all. You can check out on the chat. You can load it to your Google Drive. I've sent it onto the chat. Anybody has got it? You can say you've got it onto the chat. This is the data set, the age, sex, CP, trespass, and all the things about, and it's a processed data. And you can see target 1 means the patient, if this is the pattern of data, then the patient is a heart patient. If it is 0, then he is not an heart patient. Here you have got 300 rows and columns. See, some is 0 and some is 1. Yeah, Nirupa ma'am, got it. Thank you. Yeah, just Sudha ma'am. Thank you, ma'am. Just load it onto your Google Drive. Upload it to your Google Drive. Import NumPy. I hope this you should have done. Import NumPy as NP, Pandas as PD, Matplotlib.pyplot as PLT. Once you have typed these 4 lines, okay, and then I'm coming down. I'm mounting my drive. You have to copy. Once you mount your drive, you copy the path and then put it onto this. Because it's the CSV, I'm using CSV. If it is TSV, then I use TSV. Okay, if it is Excel, read underscore Excel. Okay, there are different things that you can use it according to your type of data. And I'm just giving shapes. Okay, shapes is for finding number of rows and columns. Have you all got the data set? Even if you use tab, you should have received it, ma'am. I don't know. See to it. Yeah. Okay. So once I load my data set, what is the type of data I said? What is the type of data? Once I load, it's a CSV, is the data type. Once I load into Pandas, it will be converted into data frame. See, because I've taken pd.read underscore CSV, everything into this variable df. So df dot, if I want to know the data type of it, the function is type of df. This is I want to find the data type. What I told it should be, it will be data frame. Let's see. This my font size of the screen is okay for you to all to see. I know somebody are using mobile and some more systems. Data frame. Thank you. So I'm taking a CSV file, which is a comma separated file. It's a benchmark UC machine learning repository. Okay, I've taken it from that. I'm loading it. So I have 303 rows and 14 columns. 13 are the features, 1 is a target. I'm finding my CSV is, what is the data type? It is data frame. Okay, there are different attributes. I said df.shape, you have seen here. Okay, then what are the other attributes I showed you? Do you remember? df.size. Shape will give me rows and columns. df.size will multiply my rows into columns. Okay. I can also give df.headup. So furthermore, when I've taken my CSV value, put it onto Pandas, and now into this variable df, which is a user-defined variable. Can you see all the 14 columns here? Because it is head off, yesterday sir should have told you, since it is head off, I would have got only the first 5 rows. Can you see the target, tal, and all the 13 rows? Okay, so we have seen the df.head. You can write out for df.type, df.size, multiplying by rows into columns, type of df.shape. Okay, because I'm taking everything into this variable df. Okay, and I'm going, if I want to know only the column names. Okay, if I want to know only the column names, click here. Okay, I can give, these are attributes, columns. which you should not have open and close parentheses. Can you see? I'm getting all the columns. How many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Out of which, listen carefully, these 3 are the features and this is the class label. Okay. So in head, I'm using this open and close parenthesis, which is a data frame method. When I don't have open and close parenthesis, it is a data frame attribute. Okay. Able to understand? I hope. Is anybody trying? I know I take these courses for 20 hours, 40 hours, but still I'm trying my level best to share it with you. Yeah, I will share the data set. Yeah. And some of you would be trying it. Yeah, thank you, Surya ma'am. Thank you, Piyush sir. And some of them have already, they have attended to my sessions, and some they are into the 20-hour sessions. Thank you all. Working, thank you, Sudha ma'am. Thank you, Jairaj sir. Okay, happy to hear. Okay, okay. Like df.trail, you'll be able to know the last few rows. Okay, the last few rows. It's 303. It indexed from 0 to 302. Okay, nice. Thank you, Celine ma'am. Okay, so I've taken this data set. First, we need to do the exploratory data analysis. Okay, exploratory data analysis. What is my target? I told, right? When we take a data set, we have a features and your target. So this is my target. So inside, what would be my values in my target? Can one of you unmute and say, or you can put it on the chat? What does my target have? Yeah, zeros on what? Thank you, Sweetland ma'am. You're perfect, right? Yeah. So I told you like columns, right? I can also find the unique values. df dot target dot unique of. Okay. How many unique values in my target? 1 or 0. Some columns I said continuous. For example, if I take cholesterol, CHOL. If you want to know how many unique values are there, df dot COHL dot unique of. Okay, you will know how many unique values are there, because something are categorical. I told one is binary, others are some are categorical. You should have remembered when I showed on the slide. Some are continuous variables. Whenever I had hash, so many cholesterol values. I know something I told it is slope. I think so. If I see slope, df dot slope dot unique of, it could be categorical. Okay, see 0, 1, 2. Some are binary, some are categorical, but my target value is 1 or 0. When it is 0, it means the patient does not have a heart disease. When my target value is 1, then the patient has a heart disease. So I can know when the values of maybe not age and sex, mostly the chest pain, the trust, the cholesterol, the fasting blood sugar, ECG, thalash, exams, all these variables, then I have the patient does not have a, if this is in this range. I have 3 or 3, I cannot go through one by one, for which I go in for exploratory data analysis, in which I'm going to find how many targets, and also it should be balanced. So one means how many of them have got heart disease. Okay, heart disease people are 165 in this data set, and 138 people doesn't have a heart disease in this 3 or 3 columns. Okay, so now coming into my exploratory data analysis, I'm going to show you df.target.value counts, plot, kind is bar, color is salmon and light blue. I can define what color for this. Okay. So this is how you can do a plot using Pandas and Matplotlib. Okay. I can also do SNS dot count plot of. Okay. So it does a count plot on its own. Okay. And coming into my information. So, okay, df dot info of. Okay. So here I can see all our integers and float. And also you remember I told you should not have category. You should not have categorical values when you work with machine learning. You have to convert all your categorical values into numeric. But fortunately, this data set has all values as integers, as numericals. And I told you the next step that you should understand before developing, you need to find whether there is any missing values. Is there any missing values? If df dot is ni of sum of, is there any missing values? Yes or no? If it is 0, which means there is no missing values. If there is some values inside, then you have a missing values. Okay. These are two important things. These are two important things. Okay. Now coming to a there is no missing value. So we have done, we are doing this data wrangling now. Okay. Okay, we have seen how to import a data set, the number of rows and columns, like more than that, some attributes I showed you. All right. Okay. Then number of unique variables. Okay. This also you can try. df dot n unique of. I hope I showed you. I don't remember. Did I show you that? Yeah. So what this n unique of will do, I showed you about unique, right? N unique will take all columns, the total count of unique values. In age, there are 41 different variables. Sex, there are 2, male and female. And also you can see in target, it is 2. Either it is 0 or 1. 0 means the patient is not a heart patient. And 1 means the data have patients. Okay. 1 means they have a heart disease. I posted it on the group. I posted it on the chat, ma'am. Ambika, ma'am. You are asking for a data set. Okay. I'm posting it again. You can get it from the chat. Okay, ma'am. Try doing it. Okay. Okay, so n unique, it counts the number of unique variables available in each column. See which is highest, which has more number of variables. I told you how many continuous variables, how many columns had binary variables, how many columns had, what do I say, the category. That is 0, 1, 2, 3, 4, only that categorical. Ordinal, for example, ordinal, sorry. Can you see? Cholesterol has got the more number of unique values. Okay. So next, and also the column name, and each column name also unique value I showed you. Okay. The next, we have to go on for descriptive analytics. You remember we spoke about descriptive, diagnostics, prescriptive. Okay. Here and also this works for only numerical data. Whenever your column, you don't have categorical data. Sorry, when you, so df dot describe, I have all my 300 rows and some columns, 14 columns into this variable called df. Can you find here? In one simple coding, I'm able to get the mean of age, the standard deviation, the minimum value, the maximum value, the top 25 percentile, top 50 percentile, top 75 percentile, maximum values. So I can see from this, a person having a heart disease in this data set, their minimum age is 29 and their maximum is 77. Not only for 300 rows, you can try for 20 lakhs, for whatever is your size of data. Within fraction of seconds, you can get it. And also, can you see everything is 303? This also could be one part type of checking for me whether there is any missing values. Then it will show this count off will show if there is missing, because when I import my data set, it's showing how many number of rows and columns. The set of number of rows are not here in count. I can definitely say this data set has some missing values and I need to work on with the missing values. You should not have missing values when you need to develop a machine learning model. The second, here it is everything is numerical data, then it is not a problem. When you have a data set with categorical data, then you have to convert it into numerical data. Okay, there are different label encoders available. Okay, so this is a descriptive analytics. So you know what is the mean value of the age. Okay, the chest pain average, the everything you get the mean value, the minimum value, the maximum value. Can you see these are all ordinal numbers? 0, okay, 0 to 4, 0 to 2, 0 to 6.2. Some are continuous. These are continuous variables. Can you see? Which will help us to understand. So this is a very, very beautiful tool for descriptive analytics. df.describeof. df.describeof. Okay. The admin ma'am will share the data set to you, and then you can start working on with it. Okay, able to understand this? Okay. And for missing, describe is for descriptive analytics, summarizes the count, the mean, the standard deviation, the minimum value, the maximum value. Okay. Missing values. Data dot, here I've given data, but however imported my data frame is df. df dot is na, which means is not null, is not available. Okay, dot sum of. So if it is all 0, you have very clear denotation, you can start developing a machine learning model. Okay, and then I'm finding my count value. I showed you the count plot also. Okay, I showed you the count plot also. Okay, able to understand how it has been loaded? Any doubts till now? Yes. So the next we are going to move on into our exploratory data analysis. Okay. So exploratory data analysis is more needed to understand your data. First, we have taken your data. Okay. I just tried a count plot here. Okay, sorry. I have not given what data it is. Okay. Comma data equal to df. Very simple. It does the count plot. See, using my Seaborn, I told Seaborn is used for visualization. As soon as I'm doing a count plot, there are different plots. Count plot, I'll show a different plots. I will show one by one. Count plot, I'm taking only my target. What is my target? Whether the patient is infected or not. I have to give my data. Which variable in data frame I have taken as df. See, SNS.count plot of x is equal to target, data is equal to df, I get my count. So it is, I have already worked out here. It is 165 and 138. People with no disease, 138, it is 165. Can you see? And this is one most important thing when developing machine learning. The target, okay, the value should be almost balanced. Say, for example, if it is 20 and 160, how can we develop a model? It will be correct. And in order to work with that, you need to work for class imbalancing. You have to balance your data set, but it's almost balanced. It's okay. Okay. Able to understand this? Now we have taken a data, we have loaded into Pandas, we have tried the attributes and methods, and we have done the descriptive analytics using df.describeof. Now we are moving into the exploratory analysis. The first thing we have done is a count plot. Okay. All right. N unique of, yeah, I've done for n unique of. How many number of unique variables? Okay. Now I'm going like as I have a target, I have a column name called df.text.value counts. So how many male and how many females are there in this data set? And I'm comparing my target column. What is my target column with my sex? So how many male, how many female? In male, target 0 means 24 and 1 is 114. One is the people with the disease 72 and 93. Okay, this is called a crosstab. Okay, I can also plot the crosstab. Okay, I'm using my pd.crosstab. Okay, with the target, I have to find how many male or how many female are infected. See, when you see this graph, okay, I little zoom it little less. Okay, so okay, when you see this, I've done a crosstab. On x-axis, people with disease, people without disease. This pink color says the female and the male. So in this, the female, how many of them are not infected? In male, how many of them are not infected? In here, how many female are infected? How many male are infected? Female and male not infected, female and male infected. Once you see this graph, once you see this plot, what is your understanding? Can you type that inference you write, right? That's more important in data science. You are able to understand what plot I've done. X-axis I've taken people with disease and not disease. In that I'm using a crosstab. How many male infected? How many female infected? How many male not infected? How many female not infected? 0 is not infected female. 0 is infected not infected male. 1 is infected female and not infected male. Yeah. Yeah, it's a bar chart. That and all I understand. Yeah, thank you, Piyush sir. You are exactly right. Male are prone to heart disease more in comparison with female, and also here. But when you see here, yeah, male is highly exposed to heart disease in comparison with female. Even not infected, if you see, female count is less and male count. So infected, not infected, almost it is more. Okay. Yes. In majority of male are not infected. Thank you, Nirpana. See, this is where you say how each of you, a same graph, okay, how each of you have given your own inference. Writing this inference is more important. Let me wait for 1 or 2. Okay. So not only plotting this, more importantly, how do you do it? Yeah, I got one thing. I just posted. It all depends upon the attention taken. It solely depends. Okay. Okay. So the next I'm going to compare with age and the maximum heart rate. So this is the exploratory data analysis. Okay. I'm here using a scatter plot with positives and negatives with age and maximum heart rate. There's a column THALCH, some maximum heart rate. So people with the disease, without disease, x-axis with the age. So when you take only this size, when people in around 30 to 40, their heart rate is less, between 160, then there is no heart disease. But the same 35 age, when their heart rate is more, then they are prone to heart disease. Here, you need to work with comparison with their age. But see, in the middle age, 50 to 60, both infected and non-infected, they have the certain ages. Okay. Any other inference you are getting it? Answers on chat. Can you see this graph? That is the uniqueness of every data scientist. The output depends upon data, but now we are trying to understand with this benchmark data, what is your understanding? Because it differs for each one. Okay. 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 Next graph is a histogram. Okay. age with the histograms. Okay, age of this data set. You can take it for any columns. Yeah, thank you, Dinakaran sir. Okay. Okay. At the age of 60, more heart disease. Okay, sir. But see here, even though their heart rate is less, they are infected with. As the age, it depends on the age, also is one of the important factors. If the heart disease is more than, if the heart rate is more than 140, heart disease is there. See how beautifully you are trying to type your inferences from the graph. Okay. Okay, this is a histogram. I don't want to explain more about histogram. You know more about it. So in heart disease, I said one column is CP column, right? You remember? One column is CP, which CP stands for chest pain. Okay. I'm trying to compare, I've compared age with my target, heart rate with my target, because I have to find what are the needed features and just visualizing it. So if df dot head of, I have one column called CP, okay, which is the chest pain column. Okay, there are 4 variables according to the 0, 1, 2, and 3. With the target, if the chest number of, I'm using a PD cross tab. Okay, listen carefully. CP is the chest pain. So this is the value of CP 0, 1, 2, and 3. I'm just finding out. With no chest pain, 104 are here, 9, 18, and 7. With disease value, there are 39 people, 41 people, 69, and 70. Okay, and also I'm using the plot. Heart disease per chest pain. Okay, heart disease per chest pain. So with the chest pain value 0, 1, 2, and 3, you remember I showed you that as a typical engineer, atypical, some 4 values what was there. But my target is whether the patient is a disease patient or not. So, and it takes the value of it. Okay. What do you understand from this graph? Understand from this graph? The values of it. Yes, sir. Okay, from this graph, only from this graph, from this data set of 303. What's your understanding? So people with chest pain, 0. It's more with no disease and less with disease. When they have the chest pain pattern as 1, they've got less, but the infected is more, which means mostly when the chest pain type is 0, they are not infected with heart disease. Once the value changes 1, 2, you see it's typically high, 3, it's more. Able to understand? So these are the person can be depending on their lifestyle. Okay, don't think about other attributes. Only with this data set. From this graph, because being a data scientist, what do you understand from this? Yeah, high into. Thank you, Gomati ma'am. Thank you. Type 3 people will get heart disease. Yes. So there is. Can you see in 0? More not heart disease, less infected. Once the type changed to 3, exactly Dinakaran sir, the people with heart disease are less, without heart disease are more. Okay, there are different factors. We cannot develop a prediction model with one attribute. There should be different attributes, how they are correlated with each other. Okay, we are just doing a exploratory data analysis. Now we are going to do the correlation. Okay, correlation. So to do the correlation, this is the function df dot correlate of. Okay, so what this correlation does? Okay, how many columns we have? 14 columns. Okay, 14 columns. Okay. I'm plotting. Okay, I'm plotting df dot. So when age is strong, because both columns are same, so the correlation is 1. Here you can say that on the diagonal, the correlation is 1. Okay, onto the diagonal, the correlation is 1. But here you see negative values and positive values. Okay, negative values and positive values. Okay, so negative values we could ignore and positive we'll be able to. So once you see with the work, you'll not be able to understand much. I'm just plotting a graph df dot correlation a heat map SNS dot heat map. Thank you, Sir Ravikumar sir. Correct. The relationship between the variables. It's a little big. I'll just zoom down. Can you see all the 14 attributes onto the X and Y? Yes. Positives and negatives. So you can take values which are positives. That could be one methodology of doing your feature selection. Okay. So correlation within seconds, you can see how they are positively correlated or they are negatively correlated. Okay. So you can also improvise this correlation with regarding to your target also. With regarding to your target also. Okay. So you can find sometimes positive or negative. So with the then you can take features which are with positive. Okay. Able to understand about correlations? Okay. Yes. Okay. Now moving on to your different graphs like while and plot, the box plot. Already we have done for count plot. Now we are into the exploratory data analysis. Okay, we are into the exploratory data analysis. The final thing that we're going to do is this is a pair plot. With the age, trespass, only out of the 14 columns, I've taken just 5 columns and I've just drawn a pair plot. I've drawn a pair plot. And the correlation that is used here is a Pearson, default as Pearson, and different correlation method also you can find it out, which would be best for you. Okay. And then this is a categorical plot. X is my target, Y is my old peak, Q is my slope, and what would be my data. So DF DT depression, okay, with the old peak. Old peak has got only 3 values, right? With disease or without disease. So you will know without heart disease, the slope value of 0 is more. Okay, with heart disease also it's a, but the level is 3.5. But here it is different. Okay, slope 0, slope 1, and slope 2 people with heart disease and without heart disease. So before you take in your data, the more important thing that you need to work on is with the data set analysis. Okay, now we are going to start with a violent plot. I've just drawn a very simple violent plot with heart disease as target, whether it is 0s and 1, and this value I've taken. So what do you understand from this? People without heart disease, the most ranges are, because it uses the KDE, which is the kernel density estimate. It's more here and it is lesser onto the top when the values increase. But you see people with heart disease, the values not increasing more than 5. But without heart disease, their level is more. Their level is more. Okay. Is it clear? This is male, female. Male and female. Okay. I've done with male and female, people with heart disease and without heart disease. How is the value of this particular variable? Able to understand this? So these plots help us to understand more about it. Okay. And the next plot we are going to do. Okay, the box plot, X as target, Y. Okay, there I've done the violin plot for the same variable. I've done the box plot here. So here you can see how is the range. So without disease, the values are less, but with disease, the values are high. Okay, so these are the things we need to do with an exploratory data analysis. Okay, so then we are going into developing of a model. Okay, how are we going to develop a model? There are 4 steps. First is data. We have taken the data and we have done their analysis. To prepare your data for modeling, just remember ASN. What is ASN? Assign, split, and normalize. So if you're taking some notes, okay, just make a note of this variable ASN. How many variables we have here? How many variables, how many columns we have? 14 columns, out of which 13 are X and only 1 is Y. Okay. You have whiteboard will come. Okay. So I have 13 columns, which are my features, and my Y will be my target. Okay, Y will be my target. So what I should do when you prepare your model, before you develop your model, I have to do 2 things. One is my splitting of data into features and target. X is I have all my things, I'm dropping my target. Y has only my target. Okay, able to understand? Then I'm going to split it into training, test, and testing set. Okay, training set and testing set. Okay, so first thing what I should do, okay, what I should do, I need to split my data set. Okay, I need to split my data set. What are the features, what are the target? So you know clearly from this what would be my target? Only 1 column, which is my target. Okay, so here can you see on my screen? Can you see my screen? I hope you'll be able to. All these are X. Okay, the age, sex, CP, all these are X, and my Y is only 1. Y is only my target. Okay, so I split my data. First, I've assigned everything. Okay, second is I'm splitting it. Okay, now I'm assigning it. X is my features. So X is containing all my features. Okay, and Y contains my class labels. That is my target. Okay, any data set, because it is classification. When you go into clustering, you will not have target. Okay, now I'm assigning what are my features, what are my target. Okay, now I'm just viewing it. Okay, so 303, we had 14 columns, now we have 13 columns because I've dropped my target here. Because I've dropped my target here, Y contains only my target. Y contains only my target. Okay, so first is assigning. Second, I am splitting my data set into training data set and testing data set. So X train, Y train, X test, and Y test. X contains my features and Y contains my target. Okay, X contains my features, Y contains my target. Okay, so all right, and so I'm splitting my data set. I'm going to train my model using 3 algorithms, using my X train, which contains my features, and Y train that contains my target. Okay, after I complete it, I'm going to test only with my X test. My learned algorithm, where it has learned the data patterns, will give me my predicted output. Then I'll compare my predicted output with Y test. Then I'll compare my predicted output with Y test. Able to understand? There will be a whiteboard. I'm not able to get it here. Let me try with the Jamboard. Okay. So what did I do first? I split my data set into features and target. Okay. I'm splitting it into features and target, and that is me assigning. Then I'm splitting. The second step, what I'm doing is splitting. And then I will normalize it. Then I'll feed into my data set. Then I'll feed into my machine learning algorithm. Okay, then I will feed into my machine learning algorithm. Here we have 14 columns. Okay. So you're able to see my screen. I have a heart disease data set.
Yes, ma'am.
Okay. So I have a heart disease data set. I don't know, it's taking much time. I'm splitting it into features, which is labeled as X, which is 13. Okay. And I am having a target. I'm having another thing as target, which carries as Y, which will have value zeros or 1, which means 0 is without a patient without heart disease and a patient with heart disease. So I'm splitting my data set into 2. Okay, I'm splitting my data set into 2. One is the features, other is the target. After I split my features into target, both I'm going to split into training set and testing set. Okay. So here I'm going to make it as X train. Okay. X train, X test. Then I'm going to split into my Y train. What Y contains? Contains my target Y test. Okay. Sorry, test. So my features contains my, so again my feature I'm going to split into my X train, X test, Y train, Y test. So how many columns I will have in X train? One of you can say how many columns I will have in X train? I don't know. How many columns I will have in X test? How many columns? Listen to the question carefully. How many columns I will have it in Y train? How many columns I will have it in Y test? So many of you are answering. I have not just opened it. Okay. Okay. Everybody correct. X train contains 13 and Y train contains only. Now I'm going to develop a model. Okay. I'm going to develop a model. Okay. Before that, after that, I do a normalizing. Okay. I'm going to develop a model. Listen carefully. Into this model. Okay. Into this model, I'm going to feed my, if my X train contains 13 columns, right? If my patterns are this, then what would be my output? So giving these two inputs as feeding into this model, it learns the patterns. My X train, if these features, then the heart disease is, if this is the feature, the heart disease is there or not. After I develop the model, okay, after I develop the model, in order to test the model, okay, in order to test the model, I'm going to give only my, I'm showing it in black. I'm going to give only my X test, okay. It will give me an output from the learned patterns, which is called PRED, which is called PRED, P-R-E-D, PRED, okay. And then I will be comparing my Y test and my PRED. And that variable is called as accuracy. That variable is called as accuracy. I'll show you a demo of it. So I'm splitting it. Then I need to normalize it. So I'm just using very standard normalizer, the scalar, standard scalar, to scale the values, okay, so that my prediction will be more. I will show you with scaling and without scaling. So you will understand. I've split my data set. 0.3 is 70% for training and 20% for testing. It will randomly remove it, and whatever is my X train will be my Y train. Whatever the column value of my X test will be my Y test. Okay. Okay. See, I'm not running this. Okay. I'm not doing my normalizer. I'm developing my model. Okay, I've used the 3 values for my model development: logical regression, logistic regression, k-neighbor classifier, okay, and then random forest classifier. 3 classifiers. I'm not, listen carefully, I'm not doing my scalar. I'm doing it, I'm developing my model, I'm fitting it my extra wide range. Okay, I'm just testing it with my, I'm just fitting it with my extra and wide range. While I'm testing it, I'm giving only my X test. Can you see here? I'm giving only my X test. Okay, I'm getting my model scores. I'm going to fit and get my model scores. Oh, I didn't run that one. I'll not run this. Okay, I'll run this. Whenever you run in Colab, you will get the column cell value. Yeah, I got 35 because it's just a function defined. So this is where the fit and score works. Okay. Can you see it is 65, 81 and 82. Okay, I'm just running it without normalizing. First only I've assigned and I split and I'm running it. Can you see? One is 65, other is logistic regression and the random forest. Okay. Okay. I've just run the 3 models. Okay. I've just run the 3 models. Now, same thing I'm going to run. But the data set, I'm going to do a scaling using very, very simple standard scaling. This is just a function defined. I'm again going to run the model because my X train and Y train are changed. Can you see from 80? Can you see here? It is, can you look carefully here? It was something around 60s, 80s, and now I'm going to run after normalizing my data set. Can you see the difference here? Can you see the difference? Yes. So assign, split and normalize. Thank you, sir. So yeah, so this is how you do a model comparison. Just taken one attribute of the accuracy alone. How do you find your accuracy? The true positives plus true negatives divided by true positive plus true negative, false positive plus false negative. Okay, false positive plus false negative. Okay, so this is the formula. I've incorporated the header files and I'm doing the accuracy here. Okay, so this is the confusion matrix. So actually what was negative, my predicted value is also negative. Actually what was negative, but it is predicted positive. Okay, so these models and the model scores. Okay, so I've done the normalizing and then we are training with 3 algorithms: logistic regression, k-neighbor classifier and random forest. This is the confusion matrix. So you can ask what ma'am, what is true positive? Because some of you are working, for some it is new. Okay, so what the true, this is my predicted value. You remember what did I say? Predicted. This is my predicted value. This is my true value. Able to understand why test also contains 0 and 1. Predicted also will have 0s and 1 because the predicted value from the pattern that is trained. Okay, from the pattern that is trained. All right. So when my predicted is positive and my true is also positive, which is true positive. My predicted class is negative. In my true class is also negative. This diagonal is what is needed. It is true negative. So true positive means both my prediction and my actual is true. True negative means both my predicted and my actual is negative, which means the person, when the person has disease in the actual value, my predicted, because I'm giving only my data, only it is modeling and giving me whether the patient is a heart patient or not. Both are same. My objective is to get these both more. False negative means actually by prediction saying the patient is not heart patient, but in my model it is saying the patient is a heart patient. That is false negative. Actually, the patient is not negative. The patient is not heart patient. But my predictor is telling the heart, he is an heart patient. So it is false positive. Okay, so it's called false. So for that, to work on with this, okay, we work with the confusion matrix. I've just used a visualizer to show for the first algorithm, K-neighbor classifier. Okay, can you see? And precision is true positive divided by true positive plus false positive. Recall is true positive divided by true positive plus false positive. Okay, and then the precision, F1 score is precision into recall divided by precision plus recall. Numerator and denominator multiplied by 2. So to get that, I can use classification report. Okay, and then I've used even a simple classifier for precision, recall, and F1 score. Okay, and these are the different parameters. Okay, these are the different parameters, ROC, AUC curve. But if I say more, those who are new to this, they'll get confused. So AUC curve, ROC, this is a perfect true positive rate curve, and recall curve is true positive. Okay, this is the PR curve. Okay, so what and all we have seen today? Yes, please. We started with what? Any of you, can you unmute and speak, please? You're not allowed to unmute. I don't know. Data science, yes, thank you, ma'am.
Unmute, yeah.
Yeah.
Yeah, we started with the examples of Corona. That is how data science is useful in day-to-day life. We started with that. Then we proceeded, with the theoretical part. That is, what are the parameters that are being considered? How the data is being the data set is available. How to make use of it. So you explained with the live examples. You had considered the heart disease as an example, and with that you had taken the data, and you end up with the hands-on how to analyze the .csv data using the Python program, and then you explained different graphs and you concluded.
Yeah, thank you so much, Adeline ma'am. Thank you for listening. I hope yeah, I said right, going to play us.
Most of them are listening to your program, ma'am.
Yes.
So through that answers, we came to know that
yes.
most of them alert only.
Okay.
So yes, ma'am.
Thank you.
Actually, it is an excellent section. First time I'm listening to your section.
Thank you.
First section, yesterday only I listened.
Okay.
Chanceless, ma'am. It was very smooth and understanding. Excellent, ma'am. The way of
thank you.
You had explained, because I was telling my kids actually, you should learn from her how to go smoothly. So it was very nice.
Okay, thank you so much, ma'am. So now we are going to play a simple quiz for just a few minutes. Okay, few minutes. I posted the link onto the chat. Kindly go to your chat, click the link, okay, and click the link and give your name. Okay, it itself will give a name. Please do not okay, the link I want to paste it. Okay, give your name and then join. Sorry, I'm streaming it on my YouTube channel also, and I don't know whether the viewers can see. Yes, only 13 of you have joined. 89 people are here. It's a live quiz because once I start it, after which you will not be able to join back to the quiz. Yeah, 28 have joined. I'll give 1 more minute. I told right, last 5 minutes we'll be playing it.
We are asking for the link again, ma'am.
They are asking for the link again.
Yeah, yes, ma'am. Link again.
Okay. I can post it onto the chat. Yeah. Yes, Vinuta, ma'am. Yeah, 34 have joined. 30 more seconds. Quick, let's going to see who is the winner of today. The most important thing, you should give the right answer. And in addition, you should also answer fast. So today we started with data science in healthcare. How to use healthcare for healthcare application. Okay, and then we have seen what are the different functional domains that you can work in healthcare. We saw about IIT Mandis, that AI. Okay, and then we saw about the classification, clustering, regression, dimensionality reduction of the machine learning, the roadmaps, and where and how and when to use. And then we started with supervised learning, unsupervised learning. Initially, I told you the difference between machine learning and deep learning. All right. And then what are the steps to develop a machine learning model? Okay, now we are going to start. Yeah, tomorrow is clustering. I just gave you an introduction. Tomorrow we'll see about clustering, how to work on that. Okay. I'm going to start now. Okay. Just simple 5 questions. Which tool is used to generate charts? Charts, the graphs, okay. NumPy, or is it Pandas, or it is Matplotlib? Just 37 of you. Very good. 31 of you given the right answer. Let me see who keeps the first place. Yes, Lakshmi ma'am, Joshita ma'am, Jairaj sir, Gomati ma'am, Surya ma'am. Yes, the first round, the first place is Lakshmi ma'am, and she is the fastest. She is the fastest. Let's move on to the second question of the day. All right. Which function is used to find the number of rows and columns in Pandas? Is it shape or size or type? Listen carefully to the question. To find the number of rows and columns in Pandas. Shape, size, it will multiply the number of rows and columns. That's the first thing I showed you when I loaded my hard disk. All right. We'll see who's going to top in the second round. Nice. Gomati ma'am is the fastest and she is on to the first place. All right. Let's move on to the third question. Answer fast to get more points. That starts the countdown. You will be seeing the question onto your mobile or laptop or iPad. What is the data type of the data loaded onto Pandas? After I load the data onto Pandas, what is the data type? I hope I shared that also during the class time. It is data frame. I told you, right? Whatever is your data type, CSV or whatever it is, once it is loaded onto the data frame, it is loaded onto Pandas, it is into data frame. Let's see who's the winner into this round. Yes, Jairaj sir, you are the fastest. On to the first place, it's Surya ma'am. First place, it's Gomati ma'am. Second place, it's Surya ma'am. Third place is Jairaj sir. Fourth question for the day, last but one. We have got one more. Prediction model is developed by who? Whether data analyst or data scientist or none of the above. Analyst or data scientist? I told you when I started the scenario before we developed. That carries this word. Thank you, Vanita ma'am. You are correct, but your answers are onto the chat. It is data scientist. Data analyst, that's the first level. Data scientists, they develop. Analysts, they do the EDA and other things. Let's see who has answered fast. Dinakaran sir has answered fast, and still on the first place, it's Gomati ma'am, and third place, Surya ma'am. The last question, it's a cumulative score. I'm not doing anything. It's all developed online. We are going to see, this question will define who's the winner with all the previous questions. Which Python package provides machine learning algorithm? When I showed the roadmap, I showed you from which package. Is it NumPy or Pandas or Scikit? Vinita ma'am, your answers are right, but it is onto the chat. Very good. 24 of you have given the right answer. Let's see who's going to be the winner. Yes. The first place is Dinakaran sir. Second, Jayraj sir. Third is Bharanidharan sir. And the fastest on the final is Anita Karthik ma'am. Okay. So these are the positions. Oh, your feedback about today's session. Informative session. Would like to practice. Wonderful session. Excellent. Thank you, Ramakrishnan sir. Yeah, even in financial sector, there's a huge demand for data analyst. I had given talks for MBA and BBA students also. The session is one of the excellent. It pulled me into the data science. Thank you. Informative. Awesome. Nice. What are the new things you have learned? Excellent. Big learning in nutshell. Flow of the session was very good. Thank you. Nice explanation. Excellent presentation. Thank you. Thank you all for giving this wonderful session. I'll just share my company's website, www.cirf.co.in. Yeah. So this is my website. We have generally we are into R&D development, and in addition we give training for students, internship, and for faculties. We have internship. If you want to experience and explore, please do join us. And for corporates, from July, from tomorrow, not from tomorrow, sorry, July 7, 8, and 9, we are having this workshop called LaTeX. You know, it's a technical tool for writing the journal papers. If you're interested, you can join to this course. We have completed image analytics healthcare course, the third or the fourth batch, I suppose. It's a 3-day course, and predictive healthcare analytics. It's fully hands-on. You will also work hands-on during the session. It's a 6-hour course. Okay, and I hope you should have understood about classification, how to take a data set and do a classification. Any other questions you have? You can post it onto the chat. I'll just share the YouTube link of today's session. If you have got doubts after such, you can. Tomorrow I'll be there with you, no problem. I'll just share the other details to you. If you're interested, you can make a note. I'm presenting my contact details. So this is what we have seen. Tomorrow we'll start with clustering, the introductions of clustering, and then how to take a data set of customer segmentation using clustering. And if there is time, I'll show you the web app development demo section. Thank you all for joining today's session. Hope it had been useful for you. Over to the organizers. Thank you. God bless you.
Thank you.
Thank you, ma'am, for such an informative and interesting session. Participants, if you have any queries, please ask, and kindly request you all the participants to fill the feedback form given in chat box. It will not be posted in WhatsApp, so kindly check it and fill it up soon.
Yes, ma'am. Thank you, Doreen ma'am. We'll meet tomorrow again. Thank you. Thank you so much.
Thank you. Bye.